All right, let's make a tree with our short Illumina 16S sequences and some good reference sequences using the SILVA website. So first, just copy and paste our short Illumina sequences into the window here. We're going to use Jake's Thermodisulfide Vibrio sequences as our example. We're going to click search and classify. I've already dropped the similarity down to 0.85 just because these might be quite different from anything in the database. Make sure we get some good neighbors. The rest of this should be fine for this. Enter a sensible job name here, click run, and then we'll just wait a few minutes for it to run here. All right, when it's finished, you click on the job, click add neighbors to cart. We can go up and look at the neighbors that we found in our cart here. These are the neighbors. You can click on the magnifying glass to see more about them. So we can see that one of these neighbors is from peat soil. If relevant, there are the paper associated with those sequences are listed here. If it's published, sometimes you can click on it. A lot of times these unpublished papers have since been published, but nobody updated the entry. So if you just copy and paste the title into Google, you can often find the paper. And in any case, you have the accession number here, and so you can always copy and paste it into NCBI, or here there's even a direct link to the European Nucleotide Archive where you can see more about it there as well. Okay, so that's how you can read more about the neighbors. I happen to remember that these DQ IDs are very familiar to me because those are my old sequences that I generated from Lost City and published in my 2006 paper. So that's encouraging that we found my old sequences that I generated a long time ago with the search. Okay, so now what we want to do is download this file. We always want to choose FASTA with gaps. This is really important. The with gaps maintains the alignment that the SILVA folks have done for us. They've invested tons and tons of time into making a really nice alignment with all of the 16S sequences. So if we choose with gaps, we retain all of that work that they've already done for us. Start export. Now the exports go to a task manager, and you have to wait for the export to finish and then click on it and then click download file. All right, that has been downloaded to my computer. I can click on it. Here it is on my computer. I can open it in a text editor, and here it is. And here are all of those gaps that we chose to be included with the sequences, which is why they're very, very long, because they are aligned. Now, what we want to do is copy and paste our short Illumina sequences into this file. So here we go, copy paste. So now, in addition to these neighbors that we exported and downloaded, we are including our short Illumina sequences in that same file. I'm saving the file, go back to SILVA, another round of sequence search, and instead of copying and pasting into the window, now I'm going to choose the file that I just added our sequences to, which is here, and this time we're going to compute tree, and this is important. We're going to add to neighbors tree, which means that we're going to use the tree. What this means is that SILVA will compute a tree using only the neighbors, and then it will add our new sequences that we've contributed to the tree. This is important because our short Illumina sequence is not good for making trees, so we're going to rely on SILVA's full-length sequences for making the tree and then insert our short sequence into the tree. If we construct a de novo tree with the short sequence, bad stuff could happen. Okay, all of the rest of this is fine. The only thing to take a look at is here under domain. If you know you have an archaeal sequence, you should change this to archaea. Otherwise, it's all good. We want to give it a good name. So this time I'll call it thermod tree, run tool, wait for it to finish. Okay, our tree has finished. We can click on it, click view in Wasabi. This will load the alignment, so now we can actually see the alignment that the SILVA folks have made, as well as the tree. So make this window bigger so we can see it a little bit easier. We can resize this. And here we can see our short sequences that we called Thermodus alpha Vibrionia 1 and 2 are grouping here with these other sequences that start with DQ27, which I happen to remember are my old Lost City clones that I published a long time ago. So that's very satisfying. And then we can also see that the closest relatives to our Lost City Thermodus alpha Vibrio are these sequences GU208 blah 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 and FJ755. So we can go back to the SILVA website, look up these IDs by adding neighbors to cart again, going to the cart, scrolling down, looking for example, GU208, clicking on the magnifying glass, and here we can see that it is from Dongping Lake sediment, and it has been published in 2012 in this paper, so we could read more about it in that paper potentially. And the other one was FJ755, this one also from a lake in China, and we can read more about it potentially in that paper. Okay, so there we go. There's some potentially interesting similarities there, but we might want to add some references to this tree that are useful references because perhaps they are named species, or we know that they are definitely in a different family, or maybe we want to test whether it's the same family or not, or we see some sequences in a tree in a paper that we've been reading that we want to add to this tree to see where it lines up. And so the way we do that is to use SILVA's browser function. So here is the browser. We know that we're interested in bacteria. We know that Thermodus alpha Vibrio is classified as Nitrospirota. I think because SILVA is smart and it knows that we just gave it some sequences in this category, it's highlighting these in bold. I'm not sure if this will always do this for you, but if you're not sure, you can always go back to those search results and the classification results to see where you should be clicking. But anyway, we can go here and here and here and here. And then, for example, we have these 3 named species of Thermodus alpha Vibrio. The accession number is AB0213. We could quickly check to see if ABO is not already in our neighbor tree here. So we can add that to our cart. We can see that we already have our cart full, so we should probably clear that and then say, I want that one. I want that one. I want that one. Okay, and now maybe we want a representative that is definitely not in the same category. So maybe here's something called Magnetobacteriales. I have no idea what that is, but it's definitely not in the same, what is this, order as our sequences of interest. So here we go, Candidatus magnetoovum mojavenensis. I'm guessing it's from the Mojave Desert. We'll add that. Maybe it's a good outgroup to our group of interest. Now we have these in our cart. We can look at them if we want, download them. FASTA with gaps, always choose FASTA with gaps. As long as we always choose FASTA with gaps and export and download, then we can add those to our FASTA file that we've already been assembling, right? So just to show you what that means, downloaded the file, here it is, open it in my text editor. Here are those 3 sequences that I just manually added. I'm going to select all, copy, and then add to this FASTA file that we had before that has our short Illumina sequences, our neighbors that we had previously found, and to that we've now added these guys, save the file, go back to sequence search again, choose this file that I just saved, compute tree, add to neighbors tree, always do add to neighbors tree, and then everything else should be fine. We're still a bacteria. Here's thermod tree 2, run tool, wait for it to finish. Okay, our tree is finished. Click on it, view in Wasabi. Here's our new tree. here are our Illumina sequences, still grouping with those old Lost City sequences, as well as the neighbors that we'd previously seen. And now we've got these additional sequences, those that we manually added to our cart, as well as some additional neighbors that it found when we chose add to neighbors tree. Okay, so we're sort of filling this out. We can very clearly show that our Lost City thermodisulfur Vibrio sequences are not in the same monophyletic group as these guys. And so if we can demonstrate whether this monophyletic group corresponds to a single genus, does this group correspond to the thermodisulfur Vibrio genus, or does it in fact correspond to the family that includes all of the thermodisulfur Vibrio, or is this a whole order? If we can demonstrate that, then we can demonstrate whether our Lost City sequences are a new genus or a new family or a new order. So jumping back and forth between these accession numbers and a name that is more useful can often be really annoying. So here's, with this one, we don't know exactly what this is, AB0213. We can go back to our FASTA file and find what it is. But that can get really annoying, especially with these environmental sequences. And so one thing you can do is you can just take a screenshot of your screen, save it as an image, and then manually write on it to take notes on what different parts of the tree are representing. You can actually go into the FASTA file and change the name, right? You can go and type a name or copy and paste the end of this to the front of it so that it shows up on the tree. That's probably a better way to do it, right? Just don't ever delete the accession ID, because if you lose the accession ID, then we kind of have lost the information of where the sequence came from in the first place. So you can go through and change all the names, save them, upload them to SILVA again, make the tree again, and then those names should show up on the tree here. Whichever one you like better, either taking screenshots and taking notes on the image or actually changing the name of the sequence so that it shows up on the tree. Another thing you can do is click on Data Export, and there are two different formats of trees that you can export. You can Google these formats and you can find free tree software that is capable of opening these files. So that you can open these trees directly with different software that is not the SILVA website. I'm not sure if you necessarily need to do that right away, but that is an option if you want to work more with these trees. But this already is probably enough for what we need to do to figure out whether our sequences are new genera, new families, or new orders. Okay, I hope that was helpful. Good luck.